everyone. We will explain how we develop and validate a high-performance no-approval classifier. Our objective was to maximize the F1 score on the test set while ensuring that the model is well-fitted, stable, and generalize the questions. First, we will need to improve the predictive performance, and second, how we assess and prove our model fit. First of all, I will affirm that our data is well imbalanced. About 22% of data is positive and 70% is negative. So we select the F1 score as our main metric since it balances precision and recall. And also to improve our performance, start with a feature engineering. We, instead of using the raw geographic and financial variable directly, we construct an interaction style indicator that better affect the repayment capability and financial stress. For example, we have created some ratio-based feature capturing income relative to no and burden the stability signals, affect long-term repayment stress. Last, we compare multiple models in this data, and first of all, we will use the logic regressions as our baseline model, and also we use the XGB boost, cap boost to compare the F1 model and find then which model is more fitable. And for the hypertuning, and for the hypertuning, we have employed Bayesian optimization to streamline search for optimal tree depth, learning rate, and regulation strength and sample parameter. We apply early stop to prevent the overfitting, and this model have achieved the average F1 score to 0.8451, with standard deviations close to 0.01. This low variance confirmed the stable performance rather than an auto optimization on a single split. And also we have the handling the imbalance of our data. Also, with the default of decision threshold, the F1 score was approximately the 0.83 in our data. And also, the threshold turning on the out of vote predictive probability and identify optimal threshold in the high 0.5, 0.3 threshold. This just increased the F1 score to opposite. We also explain with the oversampling method, but our class weight combined with a threshold turning product more stable cost validation result and avoid some potential overfitting introduced by the synthetic data. To assess the model fit, we also use some certified 5-fold cost validation instead of relying on a simple chain test split. And we have used it in a lot of places, like in this way we also use the 5-fold cost validations, and also in a lot of model, and we have used this 5 cost validations instead of relying on a simple training set test data, and this ensures each fold preserve the original 20% of positive cut ratios. And this considers F1 score across the float and low standard deviations, demonstrated that the performance was driven by a one favorite partitions. This improved the performance, stability, and increased the confidence in the generalizations. And also we have using the learning curve to visualize our model. And you can see that in a lot of places we have learning RC and learning curve in our model of the attributes which is performance the best, analyze the bias and variance, and as the training size increase, both training and validation efforts score improve them, and the gap between the training and validation performance stabilize around 0.02 to 0.03, indicating a moderate but controlling overfitting. This validation curve did not diverge sharply from the training curve, which suggests the regulations and earnest where was effective. Also, to further understanding of the training off, we have the analyze the confusion matrix persistent recall curve in a low approved setting. False positive represent approving high weeks borrowers, which increase default weeks. False negative represented the rejected credit worthy borrowers, which reduce the value and customer satisfactions. At the optimized threshold, we reduce a false positive compared to a default threshold while maintaining a strong recall. So the position recall curve showed the position we made relative high even as a recall increase, which is desirable when managing credit risks. By adjusting the threshold, we balance the growth and risks rather than brightly maximize or recall positions. And also, we test the robust across the rapid random split, compare the standalone models with the ensemble approach. While the example only slightly improved the F1 score compared to the best boosting model, it reduced the um, it reduced uh, the external data sets such as we the average alpha score compared to the best single model is slightly improved. It reduced the reliability across the fold and in regulated financial environment. Consistency, stability are often as important as a margin performance games. In the future, if we have more time resources, we could enhance the classifier by incorporating external data sets such as the regional microeconomic indicator, employment rates, and historical credits trend. This variable capture economic cycles that influence the default probability and could prove the predictive power during the jobs. And also for the productions development, we could implement the continuous monitoring. This including checking the F1 score over time, monitoring predictive probability distributions, and calculating the population stability index to detect the data drift. In summary, improve the performance through the meaningful interaction-based feature engineering, nonlinear example modeling, systematic hypermetric training, class imbalance handling were the class weighting and threshold optimizations, and robust certified cross validations. And the final term boosting was achieved out of full score approximately up to 0.86 with a stable performance across the fold and control fitting. This result indicated that the class is both susceptibility improved and operative fit for a real-world no approved decisions.